Okay, so I started off by showing you an animation of Galileo's experiment, which was very simple. He just let a ball roll down a ramp. And then I think we all agreed that the animation looked pretty realistic. So the reason why it looks realistic is that we are imitating very, very closely what actually happens in nature. So we found a way to update the position of the ball from one picture to the next, and the pictures were shown very quickly, one after the other. This is almost exactly what happens with a real ball going down a real inclined plane. Somehow, and we will investigate how, but somehow the ball's position gets updated from one instant to the next. So let me share my slides with you again and go back to the big questions that we were asking before the break. So what information does the ball need to know? And I should have said, what information does the computer need in order to tell the ball how to move? And there were two kinds of information. So one kind of information is how to start the process. This is what is known as the initial conditions of the motion. And the other kind of information that the computer needs is what is the acceleration of the ball at all times. From the acceleration, the computer can do the rest. The computer can update the velocity, and from the velocity, it can update the position of the ball.
ane ko ta pariri na la ya ku ge nisa nishi kari imenta ane ti kapsu ku ge nyuse kari imente ane lole rang go ni ane khakon chi yong go res update chi yong go res.
And then there were two trivial questions. Who tells the ball or who tells the computer what the acceleration is? Well, obviously I do. And how does the computer get this information? I give the computer instructions.
Ta shenda chi kar se na nga su draw ni stang go res ta polo te la ya nyunong ka tsu imenti su de shi ja go res te ngarang de shi ja ba res wa te kandas thop yo res na ko chaten te polo te la kandas ra yo res na ngarang ge lo le la ya kondom chi ola ten de te chon yo res.
And so now we come to the interesting situation where if we consider the real experiment in the real world, so we consider, rolling an actual ball down an actual ramp, and we ask the same questions.
Ta tanda nga su ge yang chu ta tele gi tewe gi chewa te ngye gi chu ge nang le ngye ge takshi gi chwe la ya chorang ge sangwe chi ne polo chi dus ma du gi che ba ina te ge kap su ane ne tan de ta kanda yo re se ge chwa te ane le ge yo re.
So in the real world, what information does the ball need to know how to move? And the answer to that is the same as before. The ball needs to know where it is and what its acceleration is. Now, the second big question now is who actually tells the ball what the acceleration is? And I will let you think about that question and maybe discuss it a little bit with your neighbors. See if you can think of who actually tells the ball what the acceleration is.
Ta tanda de kap su nga su ge chwa ti ro ngye gi chui gi thwe la ya ngye gi takshi thwe la ya ane polo te kanda sung chu chi gi ye me gi je sha ta chatin kari kari bu gu yo re polo te la che bai bai na ni kondon so nga so ge thuma gi ni shi tan yu se ji te ga ya nyunan ti ku yo es ta te tan je bi ga ni chwa ga la ta wa na shin ane nyuno te katsu yemen te polo te la su ge ju chi gre es ta te che su nang khu la ya tridu chin ti dus. And Alfredo, and the thing is, they have the PowerPoint.
They have what?
They have the PowerPoint.
Oh, they have the PowerPoint. Oh, they have the whole thing. Okay.
Yes,
all right.
yes.
I see what you mean. Okay. All right. So yeah, let's let's go through the answers. I was trying to create suspense, but I couldn't do it. Anyway, the answer is, and this is perhaps a little bit surprising, it's the planet Earth, the entire planet Earth, that tells the ball what the acceleration is. And now, obviously, the planet Earth cannot give instructions to the ball. The planet doesn't tell the ball, your acceleration is so many meters per second each second. So the next question is, how does the ball get this information? Let you translate.
Tanda di kap singing yola di shepa in kilagi chitang chitsa dwa tangde di ane judur chi chiga chitang dwa in bay na chitsula tanda PowerPoint di nga sasana rayo re se ngi ti kichi shepa in tanda di ka re se na ta su desho jag re se na su kola ki desho jag re se ta su kola ki da nga su kola cha tsangwa dege ne polo di la ya nyunong katsu imin se te deshe jagures imbai na ya kola ya deshe ja system bala ya skola papulo te la ya shetan chi yo ma wa ote jirwa ani ti wo te la ya jwa shenda te ka resena pulu ti la ya chatin ta ta da ti ka su nyunong gi chatin chi to yo ro ta nyunong system bala nga su ge kresha ga ram je trans kana la ya meter katsu chi jo do ge me te su go ro ote the ba de ani pulu ti la chatin ti kana sra ga yo se to atris.
Well, and this is Newton's key idea. The way the ball gets its information from the Earth is the Earth applies a force on the ball. It quite simply pulls the ball down.
다 디가레세나 뉴턴 기 코랑 거 딱스레스. 다 콜레 차튼데 간다 스토그레세나 스콜라게 폴로테 간라 시친 dom발레 텐데 차튼데 라기 요레스. 다 두셰 바이바나 스콜라 폴로테 마 팅그레스.
The Earth, excuse me, the Earth is in fact pulling the ball towards the center of the Earth.
다 폴로 다게 스콜라게 폴로테 템바이나 폴로테 강기쇼라 탱고레스나 스콜라게 티베게 초라야 마 탱기요레스.
It is this pull that gives the ball its acceleration.
다 단다게 템바테 라텐데데 아니 폴로테 라야 뉴넌디 토쿠요스.
And that's all the ball needs to know how to move.
다 폴로테 라야 코 간다슨 고체 자구요 메사게 니땅 차팅 체네 아니 다 쿠야데 단다 다가난 자리스 그 텐슈기 네 그렇지요레스.
Just like all the computer needed to know in order to draw the animation was the acceleration.
다 단다데 라야 폴로테 코 고체 간다스 자구요 메테 게 니땅테 다 콜라 테 값 쿠야데 가레스나 스콜라게 텐슈레데 미니논데 도아 다데 관계도 총거레스나 폴로 단계 가서 gurri nane polo te ko yo me se te ko tribu yo me se te baina ke kapse khoya te ane ko ke chishu te nyunong ka su yemente chi kuto china de kyores.
So the way the ball gets the acceleration from the force is this. First of all, the acceleration is in the same direction as the force. So, and this is true in general. If I apply a force on something, I push it in a certain way, the object will accelerate, that is, its velocity will change in the same direction.
다 단단가 그 슈트라 근데 그 안윤은 진정거 여러 왔다 단단히 가서 가서 니고한테 가려나 저기 인바이나 윤농게 가초데 니 슈거 제비게 가초다 총거 요리스다 가서 니고지 간라 슈지 잡아인바나 이라 윤농 종거레스 스탄발라 되게 뉴살란 주라도야치고 뉴세 주라도게 가초데 슈 잡비게 가초다 총거 요리스.
Now remember the acceleration. When we say acceleration, we're talking about two things. We're talking about the direction in which the velocity is changing, and we're also talking about by how much the velocity is changing.
한다가 지금 뉴런 세비 값을 아니 니타 니츠니 요바팅이 고요. 스탄포디 아니 뉴세틴 주란 드루이기 세대가 소리샤스 벌세대 단지제 니바티 뉴세틴 주란 드루이기 카쇼카레레세 데 니차요레스.
So we talked about the direction. The direction is the same, quite simply. How about the by how much does the velocity change? Well, that is related to how strong the force is that I'm applying.
다 가츠티 값을 다 가초데 가슬라 간라테 와 뉴는 진정거래 뉴는 가초데 슈크 가쇼단 총고 요레스 데시 요레스. 임바이나야 다 뉴는 종야티 다 뉴는 종 시스템 발라야 뉴세긴 지토코 체치어와 체티 가츠레스나 티 아니 가르사 슈가츠치 자메기 치촌단 엔조 요레스.
So big push, big acceleration. Gentle push, small acceleration.
다 게임 비자 방야 되로 비자 수천부 당바이나 유는 수천부 요바다 네 비자 흘려지 당바이나 유는 장선 요레스.
If you were to try the same experiment, let's say on the moon, so you would get a very similar result, except that the moon's pull is weaker than the Earth's pull. So the acceleration of the ball would be much smaller on the moon than on the Earth.
사단다게 저런 게 이때 다윗 땅이 아니 다시티 집바치창 제드바 임바이나 데라야 지금 점데디 땅 더우 연구요레스 임바이나야 거기 연런지요라 폴로티가 대비기 연런데 아니 디스트로이어레스 콜라 땅 대비기 연런도 트로이어레스 티 준세karlana 다윗 콜라 강기 가서베다 거기 다윗 콜라티 데스콜라리 트로이어상 아니 폴로티가라 대비기 연런데야 디스트로이어레스.
Now, this experiment has actually been done. Astronauts went to the moon in the 1970s, and they actually did this. They dropped something onto the moon, and it fell much more slowly.
아니 단다기 다시데 뭐만 드벼레스 좀 부자 든치나나야 아니 그렇지 생각된다 데비콜라 간친데티 아니 그 답으로된다 되나 유보된다 유데티 그거는 같이 멘테라야 kusugola tashi debures.
So now, if the acceleration is in the same direction as the force, and the strength of the force is directly related to the size of the acceleration, could we say they're essentially the same thing? Could we say that the force is essentially the same thing as the acceleration?
Angasu telaya, ani nyulungi kashote shuku kashotan chiparisegdu, stinanshin ni shuki chichunga tseteyan, nyulungi chichunga tsetanya ko teke dewa yusigdeshas. Timbaina ngasuge shutama nyulungi kang yubu shigres is in a digrois.
Digmaris.
No.
And the answer is no.
Yeah.
Dawa, Tiwajik Tiayura.
Yeah. He has a question.
Yes, please.
Yes.
And the Digangla Ditidwa, Nunengi Kajo, the Shuku Kajo Jigbaris.
Oh.
The acceleration is the same direction as the force left. That did Lavina Anzu Polia Namla Yura. Namla Yukdu on the Shugyang and Zula Shuk the Namla Jagura. Ya. You know, acceleration demand Doksho Yomarves. Tenshuk the Chagura acceleration. Did you Dojo Chagmandus? When you capture Chig Chagmandus, they can do this.
He's asking about the context, because when you say the acceleration is in the same direction as the force, for example, if you throw a ball in air, the force that you use to throw the ball is up. The direction is up, but the acceleration is always down. So in that case,
question.
Opposite.
Yeah, that's a very good question. Let me tell you, and I should have been more precise. When I throw the ball up, there are essentially two different stages. The first stage is when I'm pushing the ball upwards with my hand, and that is true. The force I'm applying is upwards.
Kasugure netan ti kapsim bana polo ye pig kapsim baina ngaso netan nis laya ta ko nebam nis laya ngaso chanjo chibu yo reswa ta polo ti lapa na ai pig kap te laya ani ko ge ta polo ga the pig shuti kaya ko yo re te debares.
So if you can imagine, I start with the ball. I don't have a ball, but anyway, I'll start with this. I start from rest. The velocity is 0.
Da tampon gozu ya de gochu mepi neval lo yang gozu pins tomate la ya ne nyusete le kores.
And then I push the ball up with my hand so that the ball accelerates upwards.
Da tanda de kapsa ane karsugure da tampon gumero wa gume ni ane puluti ya yupi kapsa ya chapi kapsa shuti ya jaguyo wa. Shuti ya japche ngupta puluti imbana puluti yang guyores. 아니 딘스담바 티 값을 그거 뉴는 거 가서 때 야누고 그래서 구men 그쪽에 내발라 야누고
At that point, at some point, I stop my hand and I remove my hand, and now the ball is in the air.
다 참지라야 나는 게 라빠야 비자타야티 참샤데 라빠 말 해봐 이마이나 다 니캅지라야 볼로티 아니 그 바나나 요레스.
But remember, it was moving up with my hand before then. So when I take away my hand, it continues to go up.
아하. 다 땡고한테 가레스 담발라야 니 라빠 말을 렘바 이마이나야 다 볼로티 단도 되게 제라야 야안도 요레스. 카르실라바이나 다 되게 응원때라야 라빠금 비자탄 야 비자탄 비캅스 야안도 요로. 누구 요파테 메트도 야안도 그레스.
So from that point on, only the earth is acting on the ball, not my hand.
다 단다로와 다 볼로테 라빠탄 카트레비기 니캅티기 제라야 네 볼로티간라이 테피기 슈카레레스나 아니 스콜라기 텐슈레스 라빠만코 렌사로와 니캅티탄니 티기 제라야 스콜라다 라빠탄 볼로 카트레비기 니캅티기 제라야 볼로티간 테피기 슈티카레스나 스콜라기 텐슈레스 라빠기 슈티요 마레스.
That's where I start considering the motion. At that point, the ball is at a certain height and it has an upward velocity.
다 단다티기 컵 단다기 니 데시지라기 니법 디 난게 고 찬족사데 니컵도 아닌 고츠기 스타티 가서 볼로야 누구 열다 네콜라 고 타쿠게 디 요레스타 뉴세 요레 뉴세 야카 젠트 초사 요레스.
So from that point on, the velocity is up, but the acceleration is still down. So the ball continues to rise, but slowing down.
다 디기 니법들라야 그게 뉴세티 카야레스 이만나 뉴노트르 인자 아니 볼로티 메트드 아니 고 제타 도레스.
So when I'm talking about this free fall experiment, I'm not considering the push by my hand.
라틴한 신기 단계가 속에 랑홍기 네타티케지 시험비 값을 아니 되게 값을 가지고 라빠기 고 담배자탄위게 네타티 라빠기 배자탄위게 슈티 단계게 네타티나 랑홍기 값을 쓰기요 말이스.
But you're absolutely right. Before the, shall I say, the interesting part, I am pushing it upwards with my hand. The force is upwards, and the acceleration is upwards. So it accelerates from rest to an upward velocity that's not zero.
다 단계게 저런 게 사바나신데스로 나랑게 가서 볼로타 라빠카 마트가 메라야 가리오레스나 볼로팅 구매게 내내 양코를 무작당 거를 무작당비 값을 쉬어야 자고르티 난신기에 아니 그 뉴세탄 연은 참아 이해할 수 없는 레스. 된득이오레스.
So thanks for the question, and I should say, please feel free to interrupt me at any time and ask any questions that you may have.
저들의 퇴지치에서 아니 제라 제속에 양 바로바로라 저도 바인바나 양 델 값은 저는 틸 값인 바네 저요나 샤자 당나리기스.
We have plenty of time.
맞sol에 저당에게 고도마고 있어.
Okay, so the acceleration is in the same direction as the force. The strength of the force is directly proportional to the size of the acceleration. We could ask, are they the same thing? And the answer is no, for the following reason. And I'll give you an example, and you will see right away why they're not the same thing.
단단가서 유능거 가셔도 시고 가셔도 정글에서 되샤스. 네 슈크 세대 유능거 지종다 대가도요 그래서도 스와 대나가서 그 슈당 유능 지바로에스나 지바마리스. 멤비기 니스테 가서 네 단다 비슷한 같이 지금 오는 것도 지금이스.
So what happens if I apply the same force to two very different objects? So I'm applying exactly the same force. If you like, I'm pushing these two objects with my hand. I'm pushing the ball with my hand to the right, and I'm trying to push this element to the right. and I'm applying the same force, the same strength force.
Tanda pisan di kapsa nengarang ke shui chi pa chi wa shi shi chong chi ngi bo ma ro ni gang la ya ja pa ina nga ta pisa sana lakpa ge bija ta wa ta na lakpa ge bija ta e shu se shi pa ga ne bolo te sho sa bija ta ya ta ne lang chen te ya tu sa bija ta pa ina.
You know what will happen? I will push the ball and the ball will fly off to the right. I push the elephant and the elephant will hardly move at all.
That digi temde kari bet sama hak kuris. Getting a polo de dina bija ta pa ina polo de isho sa la dugres. Imba ina ya lang chen te ga la shi tin da shi pa ching bija ta pa ina gocho kore tanga bares.
So same force, two different accelerations.
That take us in by na switchy pares in by na you know mando and us.
So this is because the elephant, and I have to be careful with my wording here. The elephant, there's a lot more stuff in the elephant than in the ball. There's a lot more matter in the elephant than in the ball.
That under the caps Junsen Karira races Tambalaya Pulu Ladruba in Bina, launching an anga suga the Penzi Katasagora, Diceti Choyo Paton, Penzi has a Mayo Patinguris.
So we measure the amount of matter in anything by its mass.
Tanga suga Nubu Chinana Yupi Penzi Manglochua, Tikangana Senja Grace, and it dices at Tigana Senja Grace.
The elephant's mass is much greater. Mass is measured in kilograms. And I wonder if you know your own mass.
Tanga suga diceted Senja Stabala, the kilogram not Senja Grace. Ne Chesu Susu ga Diseka so imaha is.
Yeah. Depending on the person, your mass will be, I don't know, somewhere between 70 and 90 kilograms or less. Most people, adults. Yeah. Do you know your own mass?
Tangasumi Tarma in Bana, as Namji said, Jessica, what at the city in Bana, Dinchini, kilogram Dinchini, Butcher, your race.
So the elephant has a lot more mass. So same force, bigger mass in the elephant, smaller acceleration. Right? Same force, less mass in the ball, bigger acceleration. So here's what Newton said. He said it's actually true that a force causes an acceleration. That is, applying a force, a push or a pull, causes an object to accelerate, and it accelerates in the same direction as the force.
Newton Newton which you and Shuchi Java in Baina. Ani that Shuchi me occurs, the Chichigala Shuchi Japana, the Settle and Yunochi Grace, Adiko Kasude, the Yuno Chepa Kansila, Shukin Yuno Chepa Grace, then I sing in Yunongo Kashote, Shuki Japi Kashota Chintones.
So there's a cause and effect relationship here. A force causes an acceleration. Definitely the acceleration is caused by the force.
That day comes a solar jet on David Jawachio. Static as a jetty, and it should jet, Delatan begin Jewity, and you know this time the Shula candidate, and you know check this.
but the mass of the object also has to do with the acceleration.
이나 양 단다 데 값서 아니 그 년능 같이 진정 민종 세대 아니 그 디셀라 양 라르기요레스.
Now, yeah, so the direction is the same. And like I said, same force, bigger mass, smaller acceleration. So what Newton said was the size of the acceleration, the magnitude of the acceleration, is equal to the strength of the force divided by the mass of the object. So the strength of the force per kilogram of the object.
단다 당긴가 수십 값으로 슈 집바지 잡바이나 양코 대체 채워요 바이나 아니 뉴런팅 총아도와 니스타바다야 아니 뉴런기 최종대 가르라레그레스나 아니 가수그레다 뉴보식 대체 킬로그램 찍게 간라야 호피게 슈체 당청고요레 스티캅신 바나 뉴런티 뉴런기 최종대 가르레스나 뉴런기 최종대 아니 슈데 데라 고바 당청고와 슈데 아니 대체로 고바 당청고레스.
So let's say that the mass of the elephant is 1,000 times the mass of the soccer ball.
그 게딩아 소게 랑친데게 되세데 아니 볼로게 되세레 답동게 쳐요 바이나.
So if I apply exactly the same push to the ball and to the elephant's acceleration will be 1,000 times smaller than the ball's acceleration.
당이 볼로 땅 랑친이 강라야 아니 슈티 집어 지천치 잡아이나 네 그거 되세디 답지기 쳐 예장 랑친라 대비기 년는데 아니 볼로라 대비기 년을레 답동지기 쳐요레스.
So this is what we call Newton's law of motion.
단다 대시작지들라야 가서 뉴턴기 고쳤던 뜻이레스.
Newton said force causes acceleration, and the acceleration is equal to the force per unit mass per kilogram of the object.
가서 그래서는 아주 수직이 연원체 당 연원체기요레스는 연원의 최종대 가서레스나 아니 대체 킬로그램 찔라야 토비기 포비기 슈체 당성 그래서.
Yeah. This is also known as Newton's second law.
단데라 양아 속에 뉴턴기 고쳐된 팀이 바식레스.
So let me tell you a little bit about Newton's laws, because there's actually more than one. There's in fact three of them.
Can you repeat that again? Because
yeah. So this is called Newton's second law. So this is because there is more than one law of motion by Newton.
단데라야 뉴턴게 텐팅이 바스그레스 다디스는 우전생가레스나 고게 고쳤던 데비기 텐팅 찔리 마요 파탱교레스.
So you may be wondering why I'm talking about Newton's second law. What happened to Newton's first law?
지나 제주 삼문어나 지금 양생가리나 그게 뉴턴게 텐팅 이바데 시작되셔. 뉴턴게 텐팅 방법까지나 공독하오레스.
In fact, there are three laws due to Newton. Newton talked about three laws of motion.
동유스 뉴턴게 아니 고쳐게 텐팅 심응무토지요레스.
I think you've heard of Newton's first law yesterday, if I'm not mistaken, but I will talk about it again. But there's a reason why I talk about Newton's second law first, and then we'll go back to his first law.
제쪽에 뉴턴게 템틴 땅보테 지네 계산 제쪽에 계산이 봐요. 나체와 이면은 아수게 양친대 시작하기 있어. ina ta tandangi tenpin tampu ngutu ma chingwa la ya tenpin yo ngutu chisha yores de la ya ko jinsen chi yes
So I'd like to end today with Newton's second law of motion, because we've gone through a lot of material today, a lot of ideas to digest. But first, I'd like to ask if anybody has any more questions about something I've said today.
ta tandanga suge 되게 디랭이 소탕기 값이 매나 가서 이 망보지 ngutu yes 아니 데 무트도 만들면 라야 아니 제선나라 다당 디랭 가서 취샤지고 삼선탄 데비게 좋아되네요 yes
Okay, well, it seems that there are no more questions. I think, nevertheless, I'd like to stop there and I'll let you end the day. And please don't push any elephants because they might get mad at you.
다 배제 좋아요 사마리 좋아 yes one question sorry.
Oh, good. Yes, one question.
gelay ngela lanchen beja matan sonsta
어디 좋았다가라니 란첸디 보도그 식든지 그 구직지가 맞아야나 식 동리 총알을 납송아 년노 테스 탭존 조시해서 구직지가 맞아야나 년노 간지지 탭기어레스
말 shoot 동리 총알세 말다 년년 개바디
아 년노 동리 총알을 납라 년노 요요자라
아하
그 구직 맞아야나 간지지 총 년노 간지지 요자레스
yeah his question
is,
his question is like for instance the about the example if you push the ball and with the difference mass of the ball and the elephant you have mentioned that because of the if we consider the mass of the elephant is 1,000 times more than the ball and you said that the acceleration will be 1,000 times less.
Mm-hmm.
And if we think in the other way, if the elephant doesn't move, how can you say the acceleration is 1,000 times less? Is there an acceleration if it doesn't move?
Mm-hmm. The elephant does move. He moves very little, but he does move. Yeah. Yeah. In the same way, and it's hard to believe, but in the same way, if and we'll talk in more detail about this later, but just as the ball, if a ball falls towards the earth, the center of the earth is pulling on the ball is actually pulling on the earth as well. So the earth will move up a little bit. It will accelerate up, but very, very, very little because its mass is much, many, many times the mass of the ball.
아니 고때 스콜라게 볼로데 슈카츠 치마 테마나신 볼로게 양 스콜라테 야양 고식식까지 당겨레스라 고 뉴능게 볼로데 간라야 뉴능테지 스콜라 초라 두고요레 이나야 볼로데 스콜라테 뉴능테지 스콜라게 초라야 야 두고요레스 야양 두고요레스 임바이나양 고가다 되체게다 쳇바 하전 첨부요자 아니 뉴능라 드여두요레베네 쳇바 하전 첨부요레스 드여두요레스
reality is sometimes a little bit more complicated. You also got to bear in mind that the elephant is not a perfectly rigid object. So if you push the elephant, what will happen is you will squeeze it a bit more than accelerate it as a whole.
뮤보게 지금 니밥 때라야 라레게 리스타 다다데 값에 만나 처럼게 랑첸테 가서 그랬다 비자탕비 값에 아니고 그쪽 땅에 잡라야 거기 뭐듯이 그랬다 랑첸 그 테스트 주의게 남바 주로야게 남바 때문에 온 그랬어.
Yeah, but the point is that the elephant does change. It is affected by force, just very little.
한다 다다데게 그 대세자가 주디가리 시스템을 슈티 제발했더니 다 슈친티 랑첸강라야 주로아 지 용화용고 레스타 고 용바인바나 주로아데 하춘 총초를 맡았던 주로아 지 용화용고 레스.
Cool. Thanks for the question. Any other questions?
다시
ini choice tanga
nye tiwa de dira tagi nganzo ane bol di ya yudi zambala ane panangala gulme gi negab jinne legir laza ta ane panangala gulme gi negab jinne legi yona ane de kabzo de nyurse de ane lego re laza ta nyurse de lego yena ya nyurne ji de la thebgo re lawda ta nyurne thebdang de gandi res de la ya
One in the example about the ball, when you throw up a ball at the top for an instant, the ball stops moving, and you have mentioned that the velocity is 0, but there is acceleration. So, so how is possible when there's velocity is 0, and you have mentioned that there's still acceleration is there, and how is that possible? How is that happening?
Yeah. It's hard to it's very hard to understand. The key is that the acceleration is a change in velocity. So when the ball reaches the top, its velocity is 0, but it's changing. So its velocity is 0 only during a brief instant in time. And then immediately the velocity turns down again. Right? So that's why this is possible. That because the velocity is 0, but the ball isn't simply floating there. The ball's velocity is changing continuously.
단단히 값이 양식고 고와 댓글란 바는 고와 랭 갖고 지요래 신변한 단단히 값을 고라야 뉴스를 고래 뉴는 되고요래서야게 내탄도 용비 값을 맞추게다 뉴는 시스템을 뉴스에게 주로와 뉴스에게 주로한테 딱 볼때 그 투시들 해피 값을 추스다 고 갖다 그렇지다 패트 다 하청 춤춘치기린라 니니치기린라 고다 되기요래 말이다 그 구매트 니와이고레스탄 구매트 베테 야 볼때 딱하나 되게 쓰기요 말이스탄 디 값을 고라야 뉴스에게 주로요래스나 뉴스에게 주로요래스 그 야를 해피게 개치마라 레코르치 같은데 양체 마이면 고츠기요와 네스탄발에 고라야 뉴스에게 주로요서 뉴는디 요 발레스 디 니탄티 간에 데시자그레스.
So acceleration is the change in velocity. And one instant, the velocity is upwards. An instant later, the velocity is downwards. In between, it has to be 0, but it's constantly changing.
단단히 값을 왕아 속에 값질라야 그거 뉴스티 안에 그 야두거스 카야 주다요레스와 마요베가스 뉴스 마슈다요레스 다 야두야도 마두야기 바로 telaya ngasula lekol heguachiores imbanaya taku yaduata maduya tegi paro ki nursegin jirwati katu manan jiron runubade giores.
I love these questions. Any others?
Trope yagodus ichitsuno na troa jemba ayos.
Get polo da lanjing yi chigwa. The da lanjing yi la shuk chigba geva ina. The Korangi la doze medawa yobe kengi and union de la giratigres.
You know, Manda,
Union Madawa Yungres. Takasi dine imba in Nas rogi. And in other than a vacuum, your vacuum. Vacuum nalola da polo cheta, any chaduchik nigan you on the gala, salazadu chikbajiga. The cola coin yigala, and is shook the chikbajiga your sagitin shude. In a Yanko Chibajiga Yunguda. ine ya da kola di gar so kurang iga gi doche madoro chado de da ani bol ni gi mas logaro
There.
ta kola gyura mate ba gar chires
In a chuba take your rest, Mandra Rimandusa.
sa kana sa du nyuno chikwa chi kana sa ge do so ro ta kongi doche madore jadan kongi la nyuno ya gyura te gu re la ra ta o de gar chires re da cha lanje da polo gi rigwa di do
His question is when you have mentioned about applying some force on the elephant and the ball.
Yeah.
The acceleration is different.
Yeah.
And when we think about the example of in a vacuum, when you let a ball and a feather fall down,
Yes.
even if they like with he thinks about the force is same, but because the masses are different, but they have same acceleration. So if we think about, if we apply the logic of the elephant and the ball in this case, how are you going to explain the difference?
Okay, there are two different situations though. When I'm in my example, I am pushing the ball and I'm pushing the elephant with my hands, and I'm making sure that the force is the same.
Tanda de kapsin bana nga so ni ta mando ani chabu res ni pi chabi kapso polo ta langchen ni cham baja ta bi kapsin bana ni lakpa gi baja ta de te ni che gan la ya shu chi chong chi kwa chi phoge je ge tapsi ta yes.
The experiment that you're talking about is different because the force that the Earth or the Moon applies is also proportional to the mass. So it's not applying the same force to the ball and the feather.
Ta tanda chorong ge tongsang ge khamni polo ta ani chadu chima sa ki chiya ge bitsun te ge nani ani kari ore sena nga so sikola ge ta tenshu sigwa nyubo gangla phopi ge sikola ge tenshu ti baina tenshu ti kange ta theken rewa ore sena nyubo ge dese ta ani rewa yorwa nyubo ge dese ta rewa yecha ani dig kapsin baina nyubo nichage polo tan chadu ni ge dese mando wa yin koro ni chela phopi shi ya ko chipa mare mando res.
There is a very deep idea here. If you think of the applying of force as the Earth telling the ball something or telling the object something, the Earth has no way of knowing what the ball's mass is or what the feather's mass is.
So nga suge samlu ta ya chi kare ore sana de la nikap de la nga suge tatsu masona this thing sabuchi yore sta nga suge kete polo te ge karso greta sukola gi ane polo ta da ge ta chadu de la ku guchu ja ko ge ni se te ta guchu ja se ge chi kati tang yo pa imbaina na ku te kati tangra ma tope ni sukola khorang la ya ani polo te gi dese ta chadu te gi dese ka so yemin shia gi thaw yo maris.
All the Earth can tell the object is what its acceleration should be.
Ta sukola ge ta nyubo cha malaya shet khade kares ne nyubo te tang guchu tang bi kapsu kursu ge nyeno ka su chi me te shet ki ores te khona shet kres.
There's more to this than that, but I'll leave it there.
Ta tele yang ko tin sa bu dra yo re sim ba na nga su tanda ni ka gu to la sha ge yins. We like to have more questions, so
Sure.
Continue.
Sure. I was intending to stop there anyway. So any more questions? Happy to answer any questions people have.
Ta draw yo ba na tang ro chi san ni draw tang boss. 고고민도
고도
다고도
올라서 사디 갱 탑게기 데 트와이스 당상게 원디 세오시라 참무서로 나랑 갱기 데 렌데 카르고송스나 아니 폴리데 남로 유두송바 라바당 카마데 갑수 딜라 테베기 아니 슈당 아니 뉴는지 뉴체 창마 아니 가조치그레스 아니 라바당 카 데서비 주고들라 아니 카르소 뉴는데 아니 올라제 마제 아니 뉴체데 야레스 디네 도주고스 아니 당에 도바 가르서스나 디 라바당 카 폴리데 라바당 카 데와이난다 마데와이난다 딜라 아니 세골레기 틴슈 테기르 테기 마레스 세골레 틴슈 다 기지 세골레 틴슈 테기 요바이나 아니 세골레 틴슈데 아니 카두이나 마로와 마인도 somba 아니 딜라 템베 아니 뉴는데 마차그도 다 가르서 라바당 카 데 마데기 케제 민도 탱고당에 디 간데 디지 소라지
his question is about is a follow-up question for the first question, because when you have mentioned about the direction of acceleration, velocity, and a force when you throw up a ball, and you have mentioned that at just before the hand leaves the ball, you have mentioned that all the direction, the force, acceleration, and the velocity is upward, and after a ball leaving the hand, and the velocity is up, but the acceleration is down. And my understanding is that the gravitational force always is there and is always down.
Yeah.
So, so can you explain that situation?
Yes. Okay. So to be more precise, and we'll talk about this tomorrow, but of course you can have different forces applied at the same time to one object.
Tanda de kolanga su ta jwa chi sanyi sheki imbena tanda ta mutu chia la kare yore sana yubo chiki gana ya shuki ri damda chi tichi la phona de yores.
Each force is an interaction with something else.
Ta tigi shu rere imbena ya ko rere ngu gane yubo shenda shita ya ko dretki chwa ta ya na drejo chi wi ge junsan la tene chung yores.
So you're quite right. When I'm pushing the ball up with my hand, there are actually two different forces acting on the ball. Let's pretend this is a ball. There are two different forces acting on this ball because it's interacting with two things at the same time. It's interacting with the earth that is pulling it down, and it's interacting with my hand that is pushing it up.
Tanda nikap te la ya ta polo tingi lapa na yang ko lapa ko beja ta bi kap su polo te ge ga la ya ane ko shu mando ani pe tep kyo re shu mando ani tep kyo se de kar sana ko shenda mando nyu shenda mando ani ta nyam te de ju te des ta de kap su chi kar re sana chi su ko la ge ten shu ko ma thang ge re shu chi de shu shenda de lapa ge shu ko yam beja tang ge re.
So when I'm pushing up with my hand, the force applied by my hand is stronger, much stronger, in fact, than the force pulling down by the earth.
Tangi lapa gam beja tambi kapsi ya drugi kapsa ngi lapa gam beja tambi gi shuki tsede ane sukola gi ma tembi shuk tsale chiwa yores.
So the net force on the ball is still upwards because the force by my hand is bigger.
Tangi lapa gam beja tambi gi shuti chiwa yo zang yobo te ga la polo te ga la ye tepe ge ta chondong mu shi sana du ko re nga zu zang shu wa zang la ki shute ane chiwi shosra wa tin stamba da ya ngi lapa gam beja tambi gi yer ge shola jeng ge shola ya choda yores.
So when this is going upwards and I take away my hand, then the force by the hand disappears and all that's left is the force by the earth.
당이 라바기 때 볼로당 카트위기 개치되와라 아니 라바가 버저당하게 쉬우대 볼로당 카트해봐라 디스탐발라 깨때네 니 볼로대간라 태비기 쉬우대 아니 스콜라기 텐슈기 쉬우대 지고레스.
But you're quite right. While I'm pushing up with my hand, then the earth is still pulling down on this.
다처럼 당기 송아대로와 니 라바가 버저당비 값스 아니 스콜라 텐슈 탱고 여러와세 저런 거 송고도 봤을 때 따따레스 나는 라바가 버저당비 값스 라바가 버저당 거래 스콜라 티 값들레 스콜라 텐슈기 볼로테마 텐텐바레스.
So another interesting thing can happen, and we'll talk about this again. We'll talk about this tomorrow. But if I just hold this in my hand, this object is not accelerating. So that means that the force by my hand upwards is the same strength as the Earth's pull downwards.
단단하게 여보다니 라바가 나나군 그쵸 매비경 우란도스 주 대비가 값세 네 가리오레세나 니 라바가 양코린 다비기 슈데다 스콜라가 마 템비기 슈니차 아니 집어치전 차대요레스 지존 집받지 가쇼도데요레스.
So this is not accelerating. That doesn't mean that there are no forces acting on it. There are two forces acting on it, including the force by my hand, but the net force is zero.
단단데 값에 두슨 구멜라 네베 값이 임바나 콜라야 뉴노 요마레스 고쇼 땅고 요마르와 뉴노 요마르와 임바이나야 뉴노 메바틸라테니 데티 쿠간틀레 슈 포코 민두 세야게 네탄테 마레 슈 포고요레스 슈가르 포코레스는 이 락바게 야라차가에게 슈치그레 스콜라게 마라템비게 슈치요레스.
And therefore the acceleration is zero.
Tellateni de deal one good tongue mepa ya chapish to ma tembi shoe in chat tata zugu yotsa, mepa chagyots and kissing she like inza, and a digi, you put digi, gana, you piggy, and you put dig in your no catsures, and you know like race.
So Newton's second law says a net force causes an acceleration. And the acceleration is equal to the net force per kilogram of the object.
The Newton gate and Tangonana, Carisena, and a Tangshuchikua, sound like a shuchike, and then you know check it is. And then you know they can get some grace and a Takarsugre, Mubotegi, Ducere, Gala Poppy, sound like shuki chichontan, and they take and do your seguris. That's why. Any questions?
Just follow up. When the ball will throw upward, at that time is net force is not going upward, right?
After it left the hand?
Yes, after we left the hand and the ball is still going upward. Means net force is the direction is upward, but then acceleration, the direction is always down.
Right,
so
right. The net force then is just the gravitational force, which points down. Therefore, the acceleration points down. But at first, the ball is moving up. So the acceleration points down. So the ball slows down.
Radanga suge genlagi tuachate lapa tangka tebi ni kapila kanda chagyo deswa. Padanga su sekolah tensu te tanto metu yo pachero sekolah tensu ki tembe ki nyonte mayo payores. Ena ko ge da lapa tebi ki jela yan metu te yang kurun gocho ya chigro. Destambala ya ko ge kasho doko yo changro. Nyonte mayo bache ane ko ge ta tambo yubi Nursete ya imba inza kasho doko yo chang ta polo de remchinte chita lugoris.
이제 넌도 디와디 더더르시 라바니 말루 서비스라 아니 폴로딜라 테비 슈디 아니 잠닝 지사이 골라기 슈치보레 송도 딘자 디파루데다 라베 루에 서비스라 콘라 카사디 룽슈지 테고라기 덴데기 룽슈데다 사이골레 아니 슈치요바 텐슈 딩이 치보르지레
It's also a follow-up question about that the ball throw up.
Yeah.
And we have mentioned that as soon as the ball leaves your hand, the only force acting on the ball is the gravitational force. And I think there should be like air resistance or force by air molecules.
Sure.
Those are the same or are different?
Sure. There are other forces. Yes, you're quite right. There's air drag and so on, but these forces are much weaker. So I'm ignoring. Also, you could do this experiment in empty space where there is no air, and the result would be the same, or nearly the same. But you're right. I'm just simplifying things a little bit so that they don't get too complicated. But yes, there is air resistance, and the interesting thing about air resistance, and again, we'll talk about this tomorrow. It's funny because you're anticipating everything that I'm going to talk about tomorrow. The force with air resistance is always opposite to the velocity. So if the ball is moving upwards, there is a air resistance pulling it down, and if the ball is falling down, there's air resistance pushing it up.
단단하게 저런 게 송바데 다가는 자리에서 단단 압수 비천 값을 스콜의 탄슈마 시메세게 요마레세테 폴리들 받은 카드를 제라에 스콜의 탄슈마 시요마레세게 네탄테 데시자비 값을 압수에 네탄테 답 두즈야게 쳇인스라 테마 도베코 간라 예슈 파데 요레 단다 저런 거 롱게 슈스고도와 롱게 슈당 압수가 롱게 슈스고로 롱라 롱게 디틀레테네 데팅 이거테 간라 포피게 워시요와 임바네 단다 데이터 데시자고 메뉴고 전선까지 시스템 발라야 롱게 템비 워시라 소파 슈키 세테 하정 총총 인상로와 단단 압수도 안에 다시제 바탕 에네 반응 감네 다시제 값을 그거 롱게 워시라 템니 고 슈첸테테 하정 총총 인상 아니 단다 디치셔 레스타 나메탄 데탄 인가 추타 비오고네 데시자고 레스 농동 고시티 요레스네 요바레스 단다가 롱금 고시탄 디게 리팅 이 선인 전자체 인스 임베네 단다 야체스 캔사바치라 가는 게 선인 전자체한테 서마체스 당번에 그럴까 지금 니데진도 지금 나한테 개체때 라이언 두스 내가 스위치 쉐바 임바나 롱금 고시가 되는 데시자바 임바나 롱금 고시티 같은 임바나야 뉴부금 고시탄 독소스 요레스와 뉴보티 야르고 요바임바나 롱금 고시티 마텐데 요레스 뉴보티 망 고시탄 고 요바나 롱금 고시티 야테데 요레스 같은 임바나 뉴 고시탄 독소레스 롱금 고시티.
At the speeds that we're talking about here, air resistance is very weak, so we can ignore it. But if you have an object that is moving really fast through the air, then air resistance does become a factor. So, for example, a very fast car, air resistance is an important factor, and it's important because you have to burn more fuel to push the car forward, for example. So at those high speeds, then yes, air resistance is a big factor.
단단한 속에 다 남진기 지금 적세 디라로 뉴세 디라로 값을 롱금 고시티 하천 총총 인상 속에 농매 당사게 됐어. 임바이나야 지금 적세 조르바이나 적세 통부 값을 내가 속에 롱금 고시티야 속에 디간라야 삼르 땅고요. 레스타 피차샤바이나 다 모타 랑코요 바kan서 랑코 하천 조건로니가 랑코 텐다로 임바이나 랑코티 땅야라야 남티 페셰땅고요. 와티 값 임바이나 그 조건 니타 그 조세 투비 값을 아니 롱근 고시라 템비 시킨테 아니 모용고요. 에스와티 값은 아속에 야 롱근 고시티 양 아속에 다 직스 잡베 값은 나로 랭고요. 에스 다트와예 다세요 세찬차인사요.
The net force zero realize like the thing among the general Karsure Labdi Jana, the Tiwat in the land Jatumas, and the gang Lawala Benaro, Lawana Jala de Devache, Yaya Mando, Maya Mando, Duco, net force the zero like the that in the Lagana, Michik Jal Tawaji Pa Jatamba Ten Shoe, chik ane yon chola jathamba thena ta phazu dugumara tudu zero re lab gres keti tudu zero re lab tangyang ma di zero re se lobchen team ba tudu jangla chik khar thir san on thagwa kharchen cheg yores thagwa de thagwa mena cheg ro ta shuk lego ina thagwa che yo maros de kharchen cheg yores shuk mena o de lab songa de len thema sa de
All right. When we talk about the net force, and you have mentioned about like holding the object in your hand while the object not moving up or down, you have mentioned that net force is 0. And when I was teaching a class in the monks class in the monastery, I was teaching a net force 0 examples. For instance, like a tug of war. Some people just pulling the rope on the both end, and if net force is 0, and that thing is not moving, but when I was asked if net force is 0, why the rope breaks?
So
I wasn't able to answer that question. So
yeah, that's a great question. And again, it has to do with the fact that real objects are not absolutely rigid. So a rope in particular, if you could see it down at very, very small scales, ultimately you have, I don't know if they know too much about atoms and molecules. Do they know about this? A little bit. So you see atoms, and the atoms are actually not even touching each other, but they are pulling on each other with very, very strong forces that are electrical forces. So basically what is happening is that they're pulling on each other with very, very strong forces. If you pull in opposite directions hard enough, you can overcome those forces. And then you will be able to separate those atoms. But those forces between atoms are very, very strong. So you have to apply forces in equal directions that are very, very strong, equally strong, in order to break those bonds between the atoms and actually pull them apart.
Tatanda kapsa nga soge pichi karisha yore sena nga soge ta achi akarsa hachang chabi ni babla chimba imba na rawa ane nga so duteng barogi koge chi changwa chi ro te karisena duteng chi te duteng jenda la ya ko tude yo mas ko pansi tu yo mas simba na koge lok shula tende te lok penshula tende te ko pete barola ya ane koge changwa chi hachang tambu chi yore swa 다 청와대 두템파르게 청와대 아니고 도래라야 슈다 독쇼라야 그거다 치파된 거 치스탄 거 슈 하장 챔부지 자고요 됐다 근데 자바이 바이나 안테고 되게 다고게 두템 판슨라야 데베치야게 청와대 도래요 됐어
A tug of war won't do it.
다다 나가서 탑바템 바이바이나 니통 정거요 됐어
But it is possible if you apply some very big forces. I'm trying to think of an example. There's a type of bridge called a suspension bridge, which the bridge, imagine a bridge going over a river, and it's held by steel cables, like steel ropes, but steel cables. And it very, very rarely happens, but it has been known to happen that because of the weight on the bridge that one of those steel cables can actually break.
한다 양아 저기 장섬색으로 왔다 장대 쪽에 삼바치고 왔다 같이 타바다 양나 자탁 따서 저기 삼바된다고 임바이나 타쳐라야 저땅에다 정해 갖고 요레스 와 자탁들 때리데 작다가 수디로 왔다 케이블 시스템 발라야 가서 chắc 그바도가 저거 배두고도가 어때 양 삼산라야 그거 지설할 때는 양그 체액이 아니던데 요레스.
So it is possible, but the forces, that just shows you how incredibly strong the forces are between atoms in the rope or in the cable.
따단데 되게 대약할 거래서나 그다 작타다 양나 토바 템비값을 토바가 바로게 지금 그 반선기 청약이다 지금 수치로 왔다 같이 챙부요 봐 됐던 거래서. I think the question is I will just repeat the question because one it's kind of difficult for them to answer when you say net force is 0, but the rope breaks.
Mm-hmm.
So it's kind of like logically difficult for them to explain because when you say the net force is 0,
okay,
but the rope breaks.
Yeah. So
his question is, why, how, if net force is 0,
yeah,
how and why that rope breaks? Because net force is 0. Force is 0.
So Newton's second law does not say anything about whether something will break or not. All that Newton's second law says, if you have a net force on something, then that will accelerate. If the net force is 0, then the acceleration is 0. So when you have a tug of war, you may be applying a very, very strong forces in opposite directions, maybe stretching the rope, but the rope doesn't accelerate. The rope doesn't go one way or the other, right? It stays put. And that's what Newton's second law says.
Tanda kapsero chungi gwate neutron ka tanchen yiba kapse karse koresena keti ani keti ngibuchi kala phopigi sangshu te la kore imba na nyuno yo maris kores ti mashi shenda deshe jago yo maris wada thapa chi thambi kapse imba na thapa thambi ki kapse ani tako sangshu te la kore chaba imba na kung te thapa te ishogla ya nyuno chigo ma yonshogla la nyuno chigo maris nyuno machu ni kabla degi ores ta neutron ka tanchen yoga ti kuna muto chigi ores.
So in the same way, I'm holding this in my hand. The net force is 0, therefore it's not accelerating, it's not going up and down. But there is still an upward force on this pushing it up, and there's some downward force pulling it down. Those forces are still there.
Tadangi lapana chi chala de shaba imbana de kapse dang guche tam maybe kapse ku gala ya sangshu te lekor sego yores imbana ya ku gala ya sangshu lekor sego re ku junsen karsila bana ku ya du yo ma du ma gumela de de yores imbana ya de la tene de ku gala ya shu phu yo mare se ni tante mare shu phu yores kachila bana ngi lapa ya da pegin ta shu te yore tinashin ge skola ge tenshu ku ma tenju ge shu te yores te ni cha yubudegan pode yores. So that was Jambayo. Any other questions?
Good. Toward that Mamadi Ndawano this Chosro. That the Labadon Polo and Katanero. And it teaches any Carset the Bolo Yal Royak and show you down any side things you more think or. That Hindi any Carset the Kunig shoot the and it's on shoe said any mal leg or somewhere. Sonshu Segrota. Sonshu Monro Yona and Carset the Polo Yal Carson and Rotu Resero. Chi Yal Bijatan don't chi any mal that thing you chagro. Martingo.
Gelage soila polo lapa tan khatebe jelaya polo ganlaya tebi shude sukula tan shu chi kuin song song
Yali Royak show you mare. 열 로에 쇼 미어yana 열 로고 말어 볼로 볼로 따다 형 못에는 열 로고 열어 볼로 못에는 열 로고데 아니 열 로에 쇼 야다 비차동 열 해 열어 콜 테비 쇼 되도 아니 사이 텐시고 마 텐고 열어 디니 쇼디니 아니 가스디 종랑 쇼도 열어 때 오늘 신은 가지고 열 있는데 반도 그래 야스러 아니 다다 아니 가르쳐 종랑 쇼디 아니 가지고 아니 말이 라운데 아니 때 간이 나서야 되다
Malaso, like tangi shui pogyo malaso ngi trigo up. His question is regarding the ball as soon as lifts its hand.
Yep.
I've mentioned that only force that applied to the ball is the force due to gravitational force. His question is, if there's no upward force, will the ball continue to move up? And in that case, since the ball still moves up, and he thinks the net force during that time is still up direction.
Yeah. Okay. So, very good question again. Remember that force causes acceleration, and acceleration causes the velocity to change. So, if the ball is moving up and the force is downwards, so the acceleration is downwards, but the ball's velocity is upwards, the ball will rise up more slowly. It will continue to move up, right? Because it starts off with a certain upward velocity. But the next instant in time, its velocity will be a little bit smaller, and a little bit smaller, and a little bit smaller. So, yes, although it seems counterintuitive, the velocity is upwards and yet the force is downwards. But all that means is the change in velocity is downwards, so the speed is changing.
Ta tanda dege nikap telarwa nikap telaya ngatsu kuyati kalana shi kuyati chikare sena ngatsu shula tendeti shuga tendeti ane nyono cheki yores shula ya tendeti nyono cheki yores ta tanda de kapso ngatsu kuala ya te yuboti ya du yores imbaina sukula ge shuti ma tengi yeza ane nyononti ma shode yores ta ya du because nyursa yarwa imbaina nyononti ma shode yeza ane nyurseti any kale ko jide do this.
So remember this picture here, all the time, the acceleration is downwards. So what that means is when the ball is moving up on this side, it goes slower and slower and slower and slower and slower and slower. It stops, and then the velocity turns around. And now it goes faster and faster because the velocity is in the same direction as the acceleration.
Tanda dege mudi ngata pa imbana ya trubi kapsu ko nyunong katu imbana ya tirdoga mardoga ta nyutse khaya shoyores ko dosho insan de jite drogores ne polo ti ma yons ta bi kapsu nyutse ta nyunong nicha khaso shipa insan ma le bi kapsu jinjo drogores.
Acceleration khajode marwes.
Yeah, the acceleration khasho marla sancha martendwa ngombutire.
Semeda motaji langano drugro langano motaji drona ani dige motadi karse velocity di phare devra ta phadona the acceleration the ma drugre esta roes zamlilma.
His question is about a moving car. If you have the moving car moving forward, the velocity is forward from the direction, and in that case, the acceleration is towards the center of the earth.
Okay, so if the car, okay, so let me begin by saying that so far we've only talked about motion in a straight line. So either up or down, and we talked about gravity, or horizontally. If the car is moving horizontally, gravity is still acting in downwards, but it's the force, there's an upward force from the road that is exactly equal to the force due to gravity down. So I can move this along a horizontal line, and all the time, the force by my hand is the same strength as the force of gravity pulling it down, right? So there's no upward acceleration. Now, horizontally, you can have several situations. If the car is moving at constant velocity, so no acceleration horizontally, then there is no net horizontal force on it. If the car is speeding up that way, then there must be a force on the car, a net force that is pushing it that way. If a car is moving that way but slowing down, there must be a net force in that direction horizontally, slowing it down. But all the time, the up and down forces are exactly balanced, and there is no net force.
Tanda take up Simbana, Tanda Natsugi, Tanda Pertan Deshajati, Sama Natsuga Puluchi, Yayu Chimata, Zoding Asu, Sukula, Tenshila Tembigi, Nitantilla tended the Deshajayo. And it tea Natsugi Yarta Marla Drag, Chentan Tula Drag, Guchuchi Yorwa, Ting Atsugi, Samluti Chipachi Chantanga Natsugi Tela, Tanda Mutaji Panduach Yorwa, or Tigi Tela Ya Peshetana and Kyoris. That under Mutati Tela Drubi Nikap Tela Ya. 아니 스콜라기 마 땡기오레스나 땡기오레 스콜라기 모타테 마 땡기오레 티 난싱기 치파 치찬치 상외기 모타테 야라 딱데요와 야 작데오 스탐발라야 디게 캅스 아니 야타 말라 드야기 무슈테 요레스나 요마레스 카라나 슈인차게타 파코 상슈치 요마르와 메트 담발라야 야만 드야기 이니넌티 요마레스 임바나타 They nikap telaya modati ko Denlord Weta Jabot Wechta take any Guchuti Yoparis, that taking Guchuti capsa, and in Atsulayata, Newton the tension tarvaina, Keti Motatitus Drugo Yopa, Kanshila Kug, Nurseti Tembo in Baina, Nursel and Jerome in Baina, and the Motate Ganlaya, Sanshuchu Puyo Maris, Sanshusena, the net for Segura, Sanshichu Puyo Maris. That take up some Motati Tinado drew capsa, Kogi. Kulaya that get a Nunchi Chungu Yopaina, Kugan Josette Chinjo and Rogo Yopaina, and who Chinjo and Rosa Kashoton Sonwegi Chosa, Sanshichu Teguioris. And it get the Modati Chitela Dugo Yopaina, Chite Dugo Yopaina, Modati Guchugeta, Nutsege, Kashole Tope, Nunga Kashole Topege, and it's Sanshichu Teguiola Coris. That take up Simbananga. Chitela Druagi, the Shutila Yako, Perseverata, Sanshuchi Yobata Mepa the Chungu Menda, and echo Jonla Duachorata, Gani Walla Duachora, they Sanshula Korchago, they speak up Sekulaya, Unity Takio Maris, Sanshula Coris.
The Polo de Yayuaina, and the Kalaya, Santenshu de la Dinipalaya, Chanyam with the Sochi Chagara. 지단 차문님도 갈아야 볼로디 양주에게 슈디 채위 갈아야 양주어와 데 제자마 아니 사인 텐슈딩이 냠도야 아니 뒤서야 양 텐슈 볼로 야유에게 슈데다 아니 사인 텐슈딩이 야 냠비 갈아야 아니 제로 차고로 슈 제자 디 갈아야 뉴르노 아니 유에스에 컨트리시게 보이나서 그 사인 텐슈 슈데야 제로 차 볼로기 양테야 돼 고니까 장염 차인자 제로 차고로 아하 데 근데
One we have mentioned about the lifting force and the gravitational force are equal. The ball is not moving, but in that case, and you still mentioned that there is the acceleration on that. How will that happen?
Sir, I'm not understanding. Is when I'm doing this?
Yes.
So there's no acceleration. The acceleration is 0.
Yeah, take up, you know, like chorus. You know, like chorus. Like chorus. Aletena, Gala get triade terre, Polo te ara Simote le stambala, and you know you're setting back. Kugumidu. Polotea te Kelagate Kadesh. Polotea hipicas, similar hipicas at this again.
Polo ya yu de kansanjine ko shu de zone any ma zagdwa. Jeda kan ngarso gi nikap chidwa. Jeda kan zi de le ya ni ngarso gi nikap de le ya ngi kar jengore tenshu gi man thya de da polo gi ya shu dingi ani chanyam chane. Ko ani zero da. Di kala ya daji nyuno yo se gi da. Jeda ngi de den gya do thogor. Man tenshu de da polo gi ya shu dingi ani paz shu gen tene ni zero chagudos. De chawaina ko di ga nyuno yo se ya de kanda chaguena as dire.
Gilagi Tangiti Lente Sons, Watikala, you know, say, you're second Jura, Ketchi, Tio, again, Jela, and Jurandugola, so you know, the Kansan Jurandugola, the Anchikela Ketchura. This question is at like when you throw a ball at the top, at the tip, when the acceleration, when the ball stops.
Okay.
And he thinks the upward force balances out the gravitational force at that instant. And during that time is like his question is, I think of that because the upward force balance out the gravitational force at the tip. I think the acceleration should be 0, but you have mentioned there is acceleration. So
okay, so the moment the ball leaves my hand, right? I'm pushing it up, and there I let it go, and then it flies up. It slows down. It stops. It starts going down. All this time, there is no upward force on it. There is no upward force. All this time, all there is a downward force, including when it goes up. And including when it stops, that's all there is a downward force. We have this idea that the force has to do with the velocity, but no, the force has to do with the acceleration, which is the change in velocity. So all this time, there is a downward acceleration, even when it's moving down. Even when it's moving up, it's slowing down, so there's a downward acceleration. Even when it reaches a stop for just one instant, there is still a downward acceleration because the acceleration just tells you how the velocity is changing, not what the velocity actually is.
Tekangalaya Taviagi Shuti Karesena, Sukolagi Tanshu Chipuris. That decaps Sansama Chetsuki Karengi Guresena, Matsukua Lantanchiki, Nursetan, you know, in Chukadeshas. Nursetan, you know, Chukadeshas. Yeah, still a lepicas, Nursele Cores, you know, like Cores, you know, like Oyomaris. That pull, you know, like Maris, Nursekin Juro like Marisacora, Nursen Jurduyorwa. Chite do chinjo do ranjuran do parwa juran do stambala lekoyo mares kun juran do yo son you know te leko chasa do marwas tanga sula mayo bikapsun you know yimba kan ye pares yan do bikapsin banaya ko you know te ye pares you know te the school agi thanshula them begin you know ma chode reswa this stambala ya tanda ko len tang asuge you set on you know nicha karsugure Kuala de Digmariswa, and the take up singers who Namjin Kuala, take Gandhi, Nursella, Samlakana Digmaris, Gales number Nursella Kore, and then you know like Comaris, you know, and then your second Juratis, Nurse Jurati, yan rubikov ne ndukore man rubike na ndukore ke chila ya nyurse lekor chopik kap tela imbena ya nyunonti yebaris la so yeah I think now is time for
Well, I just want to say thank you for all the amazing questions. Questions. And I think a lot of them were asking also about things that we will talk about tomorrow. So I look forward to seeing you all again tomorrow.
Da danda chi su draw tin da mambo tang wala thuji chi es ne chi su draw de mambo chi sanyang asu thya gi josha tang draw dus ne sanyang asu ne ti tang de gi joshi khang mo chi yong gins